video, I had discussed about linear algebra, and today I will discuss another topic, different type of metric space, which had come different type of exam, because till long day we don't discuss about metric space. So I have decided today I will just review different type of metric space. At first I will see one example which had come in GATE exam. The question is, let X be a metric space and which of the following are not in general metric space? Option 1, rho of xy equal to d of xy whole square. Obviously rho is induced metric space, and what is the induced metric space? I had discussed in my previous video briefly. At first I will highly recommend you, if you don't see my previous video of metric space and example, at first I will highly recommend you please see this video with pay attention. Then today's video would be so easy. Otherwise not. Option 2, rho of xy equal to square root of d of xy. Option 3, rho of xy equal to minimum of d of xy comma 1. Option 4, rho of xy equal to 0 if d of xy equal to 0 and 1 if d of xy greater than 0. Let's see the question. At first I will see rho of xy equal to d of xy whole square. Okay. To prove rho be a metric space, at first we have to prove rho of xy greater than 0. Second, rho of xy equal to 0 if and only if x equal to y. Third, rho of xy equal to rho of yx. And fourth, rho of xz less than equal to rho of xy plus rho of yz. At first we have to prove these four properties. Notice, since D be a metric space, so square of this obviously would be greater than equal to 0, and obviously since D be a metric space, so this is equal to 0 when x equal to y. Also when x equal to y, then obviously d of xy would be equal to 0, and also D will satisfy the symmetric property since D be a metric space, and square also will be satisfied the symmetric property. Now we have to prove the triangle inequality. For this, for triangle inequality, consider x equal to 1, y equal to 2 and z equal to 3. Obviously, for this point, D is satisfy the triangle inequality. Then rho of xz would be d of xz whole square, that means this would be 2 whole square, that means 4. Rho of xy would be 1 and rho of yz is 1 square means 1. And notice, rho of xz means 4, this is, and rho of xy means 1 and rho of yz means also 1, and 4 less than equal to 2, this is cannot possible. So here triangle inequality has broken for these 3 points. So obviously 1 is not a metric on x. Are you getting? But in the question has indicate which of the following are not be a metric on the set x. That means actually option 1 is a right option, because here indicate are not. Option 2 indicate rho of xy equal to square root of d of xy. This is obviously be metric space, because Similar to before, since d of xy greater than 0, so obviously their square root also greater than 0 and equal to 0 always imply x equal to y, and also it satisfies the symmetric property. Also it will satisfy the triangle inequality because tricky condition is the triangle inequality. For triangle inequality, consider rho of xy plus rho of yz, and rho of xy means obviously square root of d of xy, and rho of yz means square root of d of yz. Now just add both sides, then this would be d of xy plus d of yz plus 2 times d of xy times d of yz. This is not d of xy times d of yz, this is square root of d of xy times square root of d of yz. Omit this part, then obviously this would be greater than equal to d of xy plus d of yz. Okay, and since obviously d be a metric space, so this would be by triangle inequality greater than equal to d of xz. That means I have got rho of xy plus rho of yz, rho of xy plus rho of yz whole square equal to d of xz greater than equal to d of xz. That means this implies rho of xy plus rho of yz greater than equal to square root of d of xz, and square root of d of xz is nothing but rho of xz. Okay, that means rho of xy plus rho of yz greater than equal to rho of xz. So obviously triangle inequality has satisfied here. So obviously this is be a metric space, but in the question has indicated which of the following are not metric space. So option 2 is a wrong option, and rho of xy equal to minimum of d of xy comma 1. This type of question I had discussed in my previous video. I had discussed minimum of d of xy comma 2 always will satisfy all condition of metric space property. Here only 1 not 2, similar to before. So if you don't see my previous video, at first see my previous video. I have given this link in my description box. So option third is a right option, but the question has indicated which of the following are not metric space. So option 3 also wrong option, and option 4 is a discrete metric space. So obviously this is metric space, so option 4 also wrong option. Only option 1 is a right option. This is not be a metric space. Are you getting? Now I will say another question which had come GATE 2021 exam. The question is, consider the following statement. Consider P equal to d1 xy equal to log of x over y. We have to prove this is metric on the open interval 0, 1, and q equal to d2 xy equal to set of those elements absolute value of x plus absolute value of y if x not equal to y, and 0 if x equal to y. We have to prove this is also metric or on 0, 1. Actually we have to verify is this be the metric or not. Then option 1, both P and Q are true. Option 2 imply P is true but Q is false. Option 3 imply P is false and Q is true, and option 4 indicate both P and Q are false. For this, at first, since here P equal to the matrix is indicated that D1 xy equal to log of x over y, which is equal to actually log x minus log y. Obviously, this value always greater than equal to 0. Then D1 xy equal to 0 means, obviously, this means absolute value of log x minus log y equal to 0. And that implies log x equal to log y. And since log function is 1 function, then obviously this always implies x equal to 1. And this condition is if and only if condition. Are you getting? Well, and D1 xy means obviously absolute value of log x minus log y. And since this is mod function, obviously we can write this as log y minus log x. So this is actually d of yx. That means symmetric property also here satisfy. Here not d, here d1 has indicated as d1. Now we have to verify the triangle inequality. We have to verify d1 x comma y less than equal to d1 x comma z plus d1 z comma y. And obviously d1 x comma y means log x minus log y. Okay. And consider 3 point x, y, z. Then we can write this as log x plus log z minus log z minus log y. Okay. And we all of us know by triangle inequality we can write absolute value of x plus y less than equal to absolute value of x plus absolute value of y. That means this sum obviously less than equal to, we can write log x minus log z plus absolute value of log z minus log y. Okay. And this is actually less than equal to d1 x comma z plus d1 z comma y. That means d1 x comma y less than equal to d1 x comma z plus d1 z comma y. That means triangle inequality also has satisfied here. So obviously d1 is a metric on 0, 1. Now we have to prove is d2 is a metric. They given as d2 xy equal to absolute value of x plus absolute value y if x not equal to y and 0 if x equal to y. We have to verify this is metric on 0, 1. Obviously this is very easy. This is same like x as discrete metric. Just check it again. Here when x not equal to y, then absolute value of x plus absolute value y, and this value always would be greater than equal to 0, and when x equal to y, then this value is 0, then this obviously greater than equal to 0. And that means first property d2 xy greater than equal to 0, this property has satisfied. Second, d2 xy equal to 0. That means absolute value of x plus absolute value of y equal to 0. And obviously this is equal to 0 means obviously x equal to y. And other condition 0 when x equal to y. This is for x equal to y, and when x not equal to y, but when this sum is greater equal to 0, then obviously x would be equal to y. That means two condition has satisfied here. Next, symmetric condition. This also will be satisfied because when I will use d2yx, then this would be absolute value of y plus absolute value of x, and obviously this is same as, and otherwise this would be 0, and obviously this is same as d2xy. We have to verify actual property, we have to verify the triangle inequality d2xz plus d2zy. For this, at first, since here two conditions, at first consider x equal to y equal to z. Then obviously 0 less than equal to 0 plus 0, then obviously this is trivial. When x not equal to y not equal to z, then obviously d2xy less than equal to d2xz plus d2zy, because this is mean mod x plus mod y, and this means mod x plus mod z plus mod z plus mod y, and this value obviously less than equal to this value because this is big term. Consider x not equal to y but y equal to z, and since x not equal to y, that means d2xy means obviously absolute value of x plus absolute value of y, and y equal to z, that means this value would be equal to 0. Here also this part not equal, so this part would be absolute mod of x plus mod of z, and here y equal to z, so we can write this as mod of x plus mod of y. That means obviously mod of x plus mod of y equal to mod of x plus mod of y. That means this condition also satisfy. Also, when y not equal to x and x equal to z, then other condition similar to before, this is also would be satisfied, because this would be mod x plus mod y, and since here x and z are equal, so this would be 0 and this would be mod z plus mod y. Okay, and notice since y not equal to x but x equal to z, so we can write this as z equal to x, since so this is also similar to before, this is also true. So also be metric, that means option both p and q are true, that means both p and q are B metric space. Are you getting? Well, today I will stop here, and I hope my all viewers till now will evaluate this type of metric space easily, because for any competitive exam, which of the following be a metric space? This is very important for any competitive exam. So I will again highly recommend you, please see today's video with pay attention. See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.